Okay, quite a few of you are making some mistakes with these Hegarty questions. So if I just take you through a few of them. Yours, apparently these are generated randomly, so your questions might look a little bit different to these, but the principle is the same. So this question, use the cumulative frequency diagram to work out an estimate of the median speed. So looking at this cumulative frequency diagram, I can see that it runs to 40. So there are 40 data items. So the median is going to be halfway in the ordered set. Halfway of 40 is 20. So I go up the cumulative frequency to 20. That tells me where to find the median value. I then read across to the point where that line crosses the cumulative frequency graph, and then read down. So that point there is going to be, each line is 2, so that's going to be 13. So the median speed in this question would be 13 miles per hour. The next one's the lower quartile, so that's a quarter of the data. We're again measuring out to 40, so a quarter of 40 is 10. So the lower quartile will be the 10th data value. So I read the cumulative frequency to 10 and across and down, so the lower quartile will be 8 miles per hour. Upper quartile is 3/4 of the data, so 3/4 of 40 is 30. So I'm looking for the 30th data item. I'm reading across and then down, and that one will be 39. For the interquartile range, I need to work out both the upper quarter value and the lower quartile value, and then work out the difference between them. So in this one, again, it's out of 40. So I'm looking for the 30th data value for the upper quartile, which is going to be 32, 34, 36. The lower quartile, which will be at 10, which is going to be 2, 4, 5. So the interquartile range will be 36, take away 5, which is 31. Use the cumulative frequency diagram to work out an estimate of the number of cars traveling at less than 10 miles an hour. So now we're going to use the graph in the opposite direction. So rather than working with the number of data items, we're taking the context to find out the corresponding number of data items. So the number of cars traveling less than 10 miles per hour, I'm going across the speed 10 and up to the graph, and then I'm reading across the data count. So I'm going to 10, and I can see that's 12. And the value that you read off the cumulative frequency is less than. So this is telling me there are 12 data items that are traveling less than 10 miles per hour. When you're trying to find out a more than, you're still going to be using that boundary of your graph. So more than 40 miles an hour, I can read off less than 40 miles an hour, which is going to be 34. And then the number that are traveling more than 40 miles an hour then is the gap between your total number of data items, which is 40, and those that are traveling less than 40. So I'm going to be working out 40 less 34, so there'll be 6 cars traveling more than 40 miles an hour. And then the rest of the questions are similar, but now this time this graph is out of 80. So when you're finding the median, you'll be looking at the 40th data value. When you're trying to find the lower quartile, you'll be finding the 20th. The upper quartile will be from the 60th, and so on. Okay, so lots of you were getting in a knot when you were trying to read off these median, upper quartiles and lower quartiles. So hopefully that will help you realize what you need to be doing to get those answers right. If there's any problems, send me a message.